The benefits for views are for retrieval purpose only most of the time. You can see that when we create a view, we're trying to retrieve data from it most of the time. So it gives you a very simplified view of display of data and also provides a measure of security. However, sometimes you can also try to update data through a view, but there are some restrictions on it. Basically, you can update the view if the view contains a primary key. That is because if the primary key is not included inside a view, some of the data will be merged together. Therefore, when you try to update the base table through the view, the database does not know which record it will be updated to. So that will cause an error. So therefore, you cannot update the view when the primary key is not included. For example, in the following picture, if you look at the rep cred view, you can see this view. That it does not contain the primary key, so therefore of the customer information. So you don't know which customer record you're trying to update to. So therefore, you cannot update the base table, which is a customer table, through this view. If the view involves multiple tables, such as joining of two tables, and you can update the view if the join of the two tables are on the primary key of each table, so that both tables' primary keys are included in a view. Then you can update the base tables through the view. However, if one of the tables' primary key is not included, then you cannot update the base table because some of the records might be merged together. Also, if there's some other more complicated columns or view structures involved, you cannot update the base table through the view. So that will encounter more severe problem. If the view involves statistics, such as group by, and then it's most difficult to update to the base table because most of the time the base table will be, the records in base table will be merged, so you cannot update through that. If there is a view you don't need anymore, you can drop the view. Okay, drop the view will be the same as drop the table in a SQL command. You just simply type the drop view command and just follow the view's name. So don't forget to type the view because this will be the object. However, different from drop table command, drop view command will only delete the view but not affect anything on the base table. So the base table and the data will remain unchanged. Next, we're going to look at the security of a database. There are a lot of different security concepts inside the database, such as internet security, the access to the database, something like that. However, in our class, we're focusing on the data access of the database as our major concern of the security. The goal of the security in this aspect is to prevent unauthorized access to the database. So we're trying to make sure that only authorized user can access authorized data. We divide the users into different levels. Some of the users can only be to retrieve and update anything inside the database. So this is the highest level, such as the DBA. Some of the users may only able to retrieve data but not change data. And some of the users may able to access only a portion of the data. Two commands will be used to guarantee the security inside the database concerning the data access. Basically, we're going to first look at a command that is trying to give the user privilege to access data. This command is the grant command. So this is actually to grant a user a privilege to a table or some attributes of the data. So grant is to give the privilege. The privilege here inside the database includes the selection, insert, update, index, create index, or delete table, and etc. And database administrator is a major person to control different type of the privileges. So the DBA can grant different privilege and also to revoke the privilege. The object of the grant command is revoke command, which is to remove the privileges from users. And these two commands have similar formats. In this list, we included most of the examples that you will need to control the privilege on a database. The first four commands focus on granting the privilege to users. The last two are focusing on revoking privilege on users. So let's look at them one by one. The first example is to grant the selection privilege on the table rep to a user called Johnson. So after this command is executed, Johnson will have the selection, which is to view the data privilege on the rep table. This one is very easy. So basically just the grant and then select which is the privilege on which table and then to which user. The next command is to grant insert privilege on item table to two users, which are Smith and Brown, so which is also very easy. In the third example, you can see that we can control the grant to update only some of the attributes inside a table, which in here are the customer name and street. Only these two attributes are allowed to update on the customer table and by the user Anderson. So Anderson will only able to update this custom table only on these two attributes. Next is to grant the delete privilege on a table to Thompson, which is user. So these first four are the grant example. And then let's look at how to revoke. Revoke is similar with the grant. First revoke, select, which is privilege on the table rep. Instead of a to, here revoke is from a user. So you can see we can revoke a privilege on the table from a user. And the last comment is very useful. Sometimes if you have granted a user many different privileges on the table, you don't remember all of them. So in Oracle SQL we provide a command so we can revoke all. So that means all the privileges will be revoked on the table rep from user Johnson. So this is be very useful if the users no longer need any privilege on the table. Next, we're going to look at another concept which is called index. Index is a very useful structure inside a database. Index is like the index of your book, the index of your phone contact inside your smartphone. So it will be useful to speed up the searching inside your data. In database, we have index on the table, so which can speed up the searching on tables. And here is a example in the following picture. You can see we create an index on the customer table, and we create an index on the custom number column. Let's look at the structure. The index is like a table. It has only two attributes. One is the custom number, one is row number. So there are only two columns here. So it says that the customer number 126, this record, is located at the first row inside the table. Similar, customer number 260, this customer, is located at the row number 2 inside the table, and so on. So later on, if there is a searching query searching, for example, where condition where customer number equals to a number, so we can just using this index and try to locate if where is the custom number, and then this index will immediately tell me or the database where this record located at the table storage. So we don't have to search from the beginning to the end of table to retrieve that record. So this is why an index can speed up the searching on tables. In a previous example, we created a customer number index. So that's on the primary key. Therefore, each line of the index only has one record. And if we create an index on non-primary key attributes, for example, on the credit limit or on the rep number, you can see the credit limit for the 5,000 credit limit. There are two records, customers whose credit limit equal to 5,000. They're on row 5 and row 6. So later on, if there is a query searching for customer equals to 5,000, I don't have to search all the customer, but I can just look at this index and I find out only 5, row number 5, row number 6 are the record we want. So same thing for the rep number index. If we want to find what are the customers whose rep number is 15, so we don't have to search all the table, but just directly go to row 1, 6, 9, and 12. We can find those records. So this will speed up the searching on the table dramatically. The SQL can manage the indexes. We can create index, we can destroy the indexes, and then we can define an index to be created on which columns by just using SQL commands. The advantage of the index is to speed up the searching. However, indexes also have disadvantages, such as because you are trying to put the index value with the row numbers side by side into a table. Therefore, index is not a storage free. It is actually occupies some spaces on the disk. If your index is very large, then your index will occupy a lot of disk space. This will be a common problem for large data or big data when you're trying to create an index on a big data table. Second of all, if there is any data to be changed or updated, then database also have to update the index accordingly. So this will also take some extra effort to maintain the index. So these are the two disadvantages. To create an index, we can use the create and index command to create an index, and then followed by the index name, and then define on which table, on which columns to be included when you create this index. For example, here we're trying to create an index on the custom table. So here is a command. We can create index. This is the index name, BAL, which is balance, IND is index, on the customer table and on the balance attribute. And then after this command is executed, database will create on the customer table and then only include the value of the balance. So later on, if there is a query trying to search in the custom table according to balance number, the query will be speeded up. You can create an index on just one column, and you can create an index on two columns. For example, in here, we're trying to create an index called the rep name on the rep table. We're going to include two attributes, which are last name and first name. So this will include all the combinations of last name, first names, look at all the records of the last name, first names, and then it will put them into an index and their row numbers. So later on, if there's a query searching the last name, first name, the query will be speed up. So this is an example of an index on two columns. Next, if you don't need an index anymore, you can delete the index. So just using the drop index command, followed by the name of the index to be dropped. And then this will permanently delete the index, and this will not affect the table where the index is built. There is a special index inside the database. It's called unique index. Unique index is not only index but also has extra functionality, is that it will ensure that for the columns included in the unique index, the data will be unique. So after a unique index is created on a non-primary key columns, if you're trying to insert a duplicate value for that column, the database will not allow that value to be inserted. To create a unique index, you just type create unique index and then followed by the same as you create the index on the normal table. Include the column you want to include it in this unique index, and later on database will try to reject any duplicate data inserted into the columns in the unique indexes.